Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and today's we are diving into an important concept in probability, that is the bivariate discrete random variables. So if you are learning probability, statistics or AI, this topic is crucial for understanding how two variables interact. So let's get started. First of all, let us see the definition. So let x and y be two discrete random variables defined on the sample space S. Remember, the sample space should be the same. Then the function xy defined in the same sample space is called two-dimensional discrete random variable. And xy is a two-dimensional random variable if its possible values are finite or countably infinite. That means it is just telling about discrete. It is finite, that is countable, or countably infinite. So it is talking about discrete. Each value of x and y is represented as a point in xy plane. That means two-dimensional plane. And see that if we have three balls and if we place in three cells, so here we'll see that how we will define these two random variables. So the number of balls in a cell and the number of occupied cells, these form discrete random variables, and that is two-dimensional discrete random variables or bivariate discrete random variables. We'll see that here. See that how we are defining x. So number of balls in cell 1, that is we are defining, that is by x, and number of occupied cells, that is y. So here you can see that if I tell that what would be this pair, so that would be, see that number of balls in cell 1, so that is 1, and number of occupied cells, so all cells are occupied, that is 1 3, that is x and that is y. Here if I talk here, so here see that here I can tell that in cell 1, that is x is equal to 0 and y is equal to 2. Here I can tell. So see that in this way we will have 13 valid 12 valid pairs. So here these are 12. Now let us see that there are 27 possibilities and 12 valid pairs. Some are invalid. So let us here define joint probability mass function, and that is defined at pxy, here the value of x and the value of y. Now joint probability table, here you can see that x can have values from 0 to 3 and y at least, that is 1, 2 and 3. So if we tabulate that, so see that this value, if I talk 2 upon 27, so that means here x is equal to 0 and y is equal to 1. So see that what does it mean? It means that x representing, just recall that I'm recalling it. I'm writing the numbers. X is number of balls in cell 1 and number of occupied cells. So just see that. So here number of balls in cell 1 and Y number of occupied cells. That means X is equal to 0. So there are no balls, and Y is equal to 1 means there is at least one cell that is occupied. And again, two cells are occupied. But in first cell there are no balls. X0, Y0 means there is no, you can say that the value of X is equal to 0 and Y is equal to 3 I am talking about here. So that probability will also be 0. The same way you can say that for a 1 X is equal to 1, Y is equal to 1. So that will be 0. So see that this is the tabulated probabilities. Here if we talk about marginal probability mass function, so we will just add all values for x is equal to x. That means here we will accumulate x is equal to 0. That means we will add all the values for x is equal to 0. We'll see the example. So here x is equal to 0. If we if for x is equal to 1 we will add all x is equal to 2 and x is equal to 3. So here understand, here again I am showing you how it has happened. So for x is equal to 0 we will add all. So here x is equal to 1, x is equal to 0, p x is equal to 0. That means here 2 upon 27 plus 6 upon 27 plus 0. That would be 6 upon 8 upon 27. The same way p is equal to x p x1, that is we will add this row and we will get this one. P x2, for x is equal to 2 we will get this one. So this is, you can say that marginal density function. Marginal, you can say the joint probability. This one is, you can say that marginal mass function of x. There is no y involved. Let us see that here. The same way for a y we will add these values, this one, that means verticals. So this would be marginals of y. So this one. So let us see how we have calculated here. So these are the marginal probability mass function of x, and for a marginal probability mass function of y we will see that this one, y is equal to 1 we will add all, p y is equal to 2, 8 upon 27, and p y is equal to 3, 6 upon 27. Now what is the conditional probability? So conditional probability would be of this form: p x y given y And see that here, suppose that we want to find out px0 given y is equal to 2. So what will we do? We'll calculate conditional probability mass function x given y is equal to 2. So here x0 given y is equal to 2, we will have 1 upon 3. X1 given y is equal to 2, again 16 upon 18. Px is equal to 2, y is equal to 2. All the time y is 2. So that is the conditional probability mass function of x given y, the particular value of y. So hope the same way you can find out for conditional probability mass function of y given x. And so hope you understood joint probability function, marginal and conditional. These are very important in machine learning, artificial intelligence, and many models are, you can say that in algorithm or model or concepts are modeled using conditional probability in AI and machine learning. So that is very important. Hope you understood. So you can visit website for more resources and videos, YouTube channel, Facebook page, and you can also connect to PostNetwork Academy LinkedIn page. So I hope you will connect and you will support me. Thanks for watching the video.